So hello everyone. I'm Taeyong from MIDAS IT. So thank you for coming today. We are going to walk through my Mastering MIDAS Civil series of MIDAS Academy. Mastering MIDAS Civil series focuses on the usage of my various functions in MIDAS Civil. So here are today's contents. When we use the finite element model software like MIDAS Civil, we should define material properties properly to get results that we want. Various software provides their own space to support users. So MIDAS Civil also provides the function to define various material properties. When I use MIDAS Civil first time and define a material property, honestly, I was a little confused because there was a lot of options in the dialog. So I tried to get used to using the function and getting the meaning of each option for a while. I guess some of our users have a similar experience. So, and I think it is important to understand the meaning of options that software provides to get reliable analysis results. Therefore, we will go through how to use material properties function with some descriptions, and then get to know some tips for managing material properties. After that, we will see some frequently asked questions regarding material properties from Global Technical Center of MIDAS Civil. And lastly, we will take a look at material properties for the advanced analysis briefly. So now we will see how to define material properties in MIDAS Civil, and I will explain the meaning of each options in the properties and the material data dialog. Okay, let me use MIDAS Civil. So you can see this model view. So I already opened the MIDAS Civil and opened some project. So this is a simple model of MIDAS Civil. So we have solid model, solid element, and plate and beam. So I will create a material property simply. So if you want to define material properties, uh, look at the top of the model view, and you can find the properties here. And also left side, you can find material properties here. If you click this, the properties dialog will be opened. So, and also as you can see, there are three types: material, section, and thickness in the properties dialog. And each means the material properties and section properties and thickness for the plate elements. So today we will take a look at the material properties only. So to define the material property, click Add. If you click Add button, the material data dialog will be opened. So first of all, we have to check the material ID and name. So the material ID should be unique because the software identifies the material properties by using material ID. So this is must be unique number, but the the name is can be the duplicated. So you can input you can input anything in the name tab. So I will create the material for steel, and next step is select type in the type of design. So I will explain more detail after the slide. So this type, I will select the steel, and here is a steel concrete and steel reinforced concrete, and last one is user defined. If you click steel or concrete and SRC, we can select the standard called national design code. So you can select the Eurocode or British standard or AASHTO or other things. And then also after that we can select the more detailed the material data in the each national design code. So I will select anything one. And as you can see, these are the mechanical properties of each material. So we have the elasticity, modulus, and Poisson ratio, and thermal coefficient, and weight density, etc. So and the under the plus 3 data, these options is for advanced analysis. So we will take a look at after this session. So I will create the material by clicking OK button. And if you want to if you want to copy the existing material properties, you just select the material and the click copy button. So we have a different ID but same name. So now I will modify this material from steel to concrete. So you just double clicking here or click modify button. I will change concrete like this, and also I will select anything here. So this time I select the Euro code and this type of concrete model. So as you can see under concrete tab, we got the mechanical properties for concrete material. And this time I will click as well. And if you want to import the material properties from the previous project, we usually use import button. So just click import and then find your previous project. So I will use material. And if you import the other project, this dialog will show the material properties in the previous project. The that project file has 7 material properties, but we have already steel and concrete, so I will deselect these 2 materials, and I will import this material here. And also under the numbering type, there are 2 types: the keep ID and the assign the UID. So if the ID number is not duplicated, you can use keep ID. But if you need UID number, use this. So I will use keep ID here. So after clicking OK button, the all material property will be imported. And if you want to delete some of them, just click and click delete button. And the last one is in renumber. Renumber option is changes ID numbers of material properties. So just click renumber, and you can click some of them and input some value in the started number and the increment to assign the UID number. And also below them, at the bottom of this dialog, we can see the change elements material number, because each element in MIDAS civil have their material ID. Let me see. So when you see the element in the table format, they you can see the which element has the which material and which properties, etc. So here's the material tab. So the beam number 1, element number 1 has the number 1 material properties. But let's go back to renumber. If you if you don't check the change in elements in material number, the material properties will the number ID number of material properties will be changed individually regardless element. But if you check on this option, uh, the element number will be changed, and also this material number in the element will be changed too. Okay, let's go back to presentation. So I explain all of this. So after this seminar, you can follow these steps. Okay, renumber, and I would like to introduce the material data dialog more detail with the presentation. So as I mentioned, material ID shows the ID number of materials, and also we can input the name to identify the material properties, but the software the various data in the MIDAS Civil use the material ID number only, so we can input the same name to the multiple material properties. Okay, next one is type of design. Type of design provides four types: RC, reinforced concrete and steel, and SRC. SRC is short for steel reinforcement concrete. And last one is user defined type. So if we select steel RC and SRC, we can select a material data in the selected design code, and also we are able to use the mechanical properties that are imported automatically. So these are the mechanical properties, and then we can find the none in the database. If we select none, we can modify the value of mechanical properties. Let's see the shortly. So we can find none type. So after selecting none type, we can modify this directly here. And then and if we select a user defined type, we can define our own material data. And actually, the main purposes of selecting type of design are to use material data in the design code or to use the design features in MIDAS. Therefore, if you input the same values into the mechanical properties as the values from the database, the same analysis results will appear. So we don't care about standard or user-defined type, other things. And all of the database under the standards is shown as the short name in the MIDAS table, like this. So I think it is important to know what the database means. So here is the table that shows some database in MIDAS and what they mean. This case is for steel. And if you want to get more detail, please check the online manual. And this case is for concrete. And I'd like to give you more detail about type of design and design features in MIDAS Cebu. If we select steel RC or SRC type, software will take the material data over to the design dialog. So each design mode has an option to define the material properties for design. So this is the material defining material properties for design mode. But if you select the standard type, some material will be this material will be taken over to here. So design features is available for the PSC, steel, RC, and SRC, and composite. And those modes have each option for material as shown in the figure. So for PSC design, this option show the PSC design material, and other types show the modified or steel and concrete, SRC, and other types. So each option about material is to define material properties for design calculation. After checking design calculation results, we can do trial and error method to modify material properties here. Even if we modify material properties that are defined for the analysis are taken over here, performing analysis isn't it needed, because the analysis features are the design features are working individually. And this is a figure for the available code for the PSC design. And this figure shows other type for the other design mode. So from the design features, MIDAS provides the Excel report that checks the section capacity under SLS and ULS. So this is some example for design report. Now let's move back to the material data dialog. So the next one is the type of material. So you can select the isotropy or orthotropy type here. So, but the isotropy type is a common type for the material. But if you need to consider different stiffness in the orthogonal direction, the orthotropic type is used. And after selecting a material data, we can see some values in the mechanical properties under steel or concrete. The first one is the elastic modulus. It is used to calculate the stiffness of elements mainly, and also it can be used for thermal laws and calculating shear modulus and so on. So we can use a value from database or input the value manually referring to the design code like this, or material specification. And next one is Poisson ratio. It is used to calculate strain and stress and shear modulus of elements. And next one is summer coefficient. It means the linear summer expansion coefficient. When we consider temperature loss, we should input a value for summer coefficient. So it is used to calculate the strain due to the difference of temperature. MIDAS provides two temperature units. One is Celsius and the other is Fahrenheit. We can select one on the unit system function. Let's go back to the software. So you can find the unit system at the bottom of model view simply. So, but this unit system just shows for the force and length only. But if you want more detail about unit system, go to the tools menu, and on the left side you can find the unit system function. If you click here, you can choose a more detailed units for your analysis. Okay. And the next one is weight density. It is used to calculate the self-weight of a model and mass. and also math for the dynamic analysis. So, and under the weight density, we can see use mass density option. So basically the mass density is calculated via the formula that the weight density divided by the gravity acceleration. So if this option is checked on, the gravity acceleration that is included in software will be used. But if this option is checked off, the gravity acceleration that is a custom value in the structure type function will be used. So you can find the structure type in the structure menu, and on the left side here is a structure type. So if you click this, you can find the gravity acceleration. So this value will be used to calculate the mass. Okay. Okay. Next content is tips to manage material properties. So sometimes we use the same material properties repeatedly. So entering values from scratch could be time consuming. So we need the import option or other ways. So we will discuss about import materials, and I show you some graphical options of model view regarding materials. Lastly, we will see other options that are related to material properties. So now we already know about the import function, how to uh, how to use it, and how what results we can get. Let's go to another approach to import material properties. Okay. The first approach is use mst command. So let's move on to tools menu and find the mst command shell. So mst command shell shows the data as a text format. So I will find the material. The command name is material, and click insert data. Oh, sorry. So we can get this kind of text. So this side means the command for the material to declare the declare creating material, and the bottom this side is the data in the material properties in this model. So I will copy all of them, and I deleted all material properties here. And let's guess. Let me guess. This project. Project doesn't have any material properties, and I know the command of material properties, or save the material save this text into the other text format. So I would like to import those material properties here. So in this case, move on to the mst command shell, and then paste that command and click run. So after running this, I got the material properties here. So in the same way, if you have any previous project, you can extract this mst command for material properties. So you can copy that text and paste into the new model. So you can import the material properties more easily way. And let's see other ways. Another approach is similar to the MCT command shell, because I will export the MCT command file. So here export and MCCB MIDAS MCT file, and then I will save this command file. So the MIDAS project can be saved as two types. So one is the model file and one is the text file. So I think the text file has a more smaller data space. So it would be a good way to save your model data. And find the material here. So this text means the material data of this model. So you just copy this command to the another text format like Excel or other text format. And save this text in this file just. And when you start your new project, and just copy this text and paste this text by using MCT command shell or the import MCT file directly. So okay, so we uh, took a look at the two approaches about import material properties. So one is MCT using MCT command shell, and another one is use MCT file. Okay, and let's have a look at about graphical option regarding material properties. I will open another model here. Okay, I opened another project, and when we start the MIDAS project, we can see the blue screen and the element which has blue color. But sometimes we want to change this element color. In this case, we will use display option. And here is draw tab. And select the element color here. And then as you can see, here is a material color. And I will use random color here and click apply. So random color will be assigned it to the element model, but the color means is the blue element structure have a same material, and green one is and also like this. So let me see. So the number one material has a green color, and the concrete has a blue color like this. And if you want to change this material color, go to the color tab, and at the bottom of this select item dialog, you can find the material. So here you can change the more detailed color here, like this. So when you make some figures for your report, you can use this option to show the colorful element model sometime. And also, if you want to distinguish the elements and to check at once, I think it would be good change the element color here. Okay, and these are the other options related to the material properties. So first one is bill of material. So this function gives us the quantity of model structure based on model. So let's see. You can find that option is in the two menus. And here is bill of material. These are the method for generating the quantity of element. So I will check on the all of things and if you click OK button. So I can get some their length or paint area or weight of about structure as per the section name or the material like this. So it would be good if you want to check the quantity of your structure approximately. And then second one is the initial material database. So do you know the standard type in material data dialog can be changed? So if you use this option, you can set the standard design code that you prefer. So let's see. So it means when you define the new material properties, and when you select the steel or concrete as SRC, you can see the Eurocode at first. But if you use this option, so preferences of function is in the tools menu, and then you can find where is it? Properties. So here is an initial material database. I set Eurocode, but if you usually use British standard, change that like this and click OK button. Okay. And when we add new material properties, the British standard will be shown at first. So I think this is a small tips for you for using MIDAS. And the next one is element weight table. So through this function, we can get total weight of element selected. So let's try. So first of all, select the material, select the element here, and go to the query here, and we can find the element weight table. So click this. So this table will show the total weight and the unit weight for the selected elements here. So you can check the material number and section and the length and unit density, unit weight, and total weight like this. So this is the more tip. And another one is mass summary table. So for the dynamic analysis, we need to change static load and the elements to the mass. So after converting work, we are able to check the mass in this function. Let's move back. Okay. So in order to use convert the structure to the mass, we should use a structure type function here. And then we can find the convert self weight into massivity. So here. So if you check on it and click OK, We can find the mass summary table under the query menu, and if you click this, we can check the mass at the node as for each node, like this. Okay. So those those thing was those thing were the small tip for the material properties. So this session is about frequently asked questions from Global Technical Center on MIDAS. So I brought the 3 questions regarding my material properties. So let's go through it. The first query is, why does the design report show different elasticity modulus? The elasticity modulus in material data isn't used. So as we know, if we select concrete, steel, or SRC material, the standard can be selected, and the imported material will be taken over to the design feature. So the user guess that this this elasticity modulus will be used for the design calculation. But so the user entered 29,725 megapascal for the elasticity modulus. But after generating the Excel design report, the design report showed 3,259 megapascal. So why these differences happened? The key is the non-type in the standard. The user selected non-type in the standard, so he needed to input values to define the concrete material for design. So based on the specific compressive strength here, so he inputted his value here. The elasticity modulus were calculated according to the formula in Ashto code here. So I got handy calculation results as a so I followed this equation to calculate the elasticity modulus. So I got handy calculation results as the same as the elasticity modulus in the design reports, like this. So this is another case to verify this issue. So I selected material data in the standard, like this. So after that, I checked the material data was selected for the design. So for the design, the same material was used. And as you can see, the elasticity in the report and the material dialog are the same. So all of I got the same elasticity modulus. So therefore, we should check each material option in design feature if we get unexpected material in the design report. Because the design report, to calculate design, we have to input the material for design mode in the modified concrete material or other PSC design material like this. Okay, this is the second query. The question was, why do we select material properties again when we define composite or SRC section? So as you can see, the MIDAS provides the composite section and SRC section. Advantages of those sections are that we can get section properties in before composite and after composite easily. And if we have a construction stage analysis, we can define the construction sequences in the same model file. So these sections have the material option that is highlighted here. So we have to select the material here. Okay. So let's check the meaning of each symbol. So the E, you can see the E. E means the elasticity modulus or Goddard and steel, and the slab like this, concrete. And the P means the Poisson ratio, and the D means the weight density. And the last one is T. T means thermal coefficient. Okay, let's check the reason. The first reason why we select material properties again is to calculate section properties considering a material in subsection simply. So after selecting the material, this composite or SRC section dialog will calculate their section properties before the composite and after composite. So if you want to check that section properties, click the show calculation results. So based on the material or the ratio, this value will be calculated. So the ratio of elastic modulus and Poisson ratio and weight density is used to calculate the section properties like area and moment of inertia and centroid position of section and etc. after composite work. And this is more description about the ratio of weight density. So when we create elements that have a composite section, we can assign only one material into the elements. So software needs information about subsection. Subsection means, in this case, the slab section. So because of that, we need to input the ratio of weight density and thermal coefficient. So this figure shows an example regarding the ratio of weight density. So if the ratio is 0, the part 2, which means the slab part here, is not counted as the weight force, self weight force. Okay, and this is the ratio of thermal coefficient. So this option is used for specific function called beam section temperature load. Through this option, we can consider the thermal gradient of section. So here is a short calculation for comparison of thermal coefficient. So in order to compare the effect of the thermal coefficient ratio in the composite section, I prepared this quick handy calculation. So as a result, the results show the different value according to the ratio of thermal coefficient. So this case is thermal coefficient ratio is 1, and this case is 2. Those cases show the difference, the reaction here. And the last query is which material should I assign to the element if I have many material properties and have a construction stage analysis. So we can discuss this issue in two cases. So case number 1 is considering the composite section without the construction stage analysis. So in this case, assign the material of main part, such like as a Goddard, and the sub part will be recalculated with the ratio material in the section to define equivalent transformed section. So in this case, the main part is the Goddard section, and sub part is slab. And case number 2 is considering the composite section with the construction stage analysis. When we consider the construction stage analysis, we use composite section for construction stage option, like this. Because this option have to see the construction sequences of the composite section. So in this option, we need to select material types again to assign different material to each part here. So each part means the gutter, slab, or other things. And the section properties will be recalculated using this material again. So we can check their stiffness or the properties value here. So therefore, the method of case number 1 will be ignored. But it would be good to know which material is assigned it to elements, because the material type here, material, in this option has two types, the material and elements. So if you select the material type, the part 1 will have the number 1 material type, and if you select the element type, part 2 will have material which is assigned it to the element here. Okay, this is the last contents of this webinar. So MIDAS Civil provides material properties for advanced analysis cases such like dynamic analysis and nonlinear analysis. So today we will take a look at each option briefly due to the time limit, and we will see the more deeply in the another webinar. Let's see. So first one is plastic material properties. So when we define the material properties, we can see the plastic data option at the middle of the dialog. Well, let's see. Here, we have plastic material name here. So if we need to check plastic behavior of structure model, select a plastic material. So we can define the plastic material in the plastic material function. And this option provides several model to consider the plastic material type. Okay, and this is in elastic material properties for fiber model. So in bridge design field, this option could be considered when we have the nonlinear seismic analysis that includes in elastic material properties. Oh, oops. Yes, like this. So fiber model means the program that divides this section and take over the element section here, and then the software divide each section as a cell, and the software will assign the nonlinear material properties into the steel cell or concrete cell and the reinforcement cell, like this. Okay, so next one is thermal transfer option. This option will be used when we have heat transfer analysis and thermal stress analysis, like this. But yeah, in MIDAS Civil, we can do the heat transfer analysis and thermal stress analysis via the heat of hydration function. So you can find this function in the load tab, and on the next side we can find heat of hydration. So these are about the thermal transfer option. Okay, let's move on. Okay, really last one. Yeah. So last one is damping ratio. The damping ratio is inputted automatically when we define a material property. So and you can see this option at the bottom of the dialog. So let's go back. Okay, here is the damping ratio here. Okay, so the damping ratio is used for the dynamic analysis such as the response spectrum analysis and the time history analysis and etc. So various methods for the damping ratio is provided for the dynamic analysis in MIDAS. So when we considered using group damping option that assigns the same damping ratio as per materials, sections, and boundaries, the damping ratio in the material properties will be used. Okay, so you can find the group damping in the under the properties menu, and here's group damping. So there are two methods for the group damping. So if you select the material data here, so you can select each material properties here. Okay. Okay, so today we have a time to walk through about material properties function in MIDAS. So I hope it was informative and helpful to you. So if you have any question, please write down on the question board. And if you need more information about MIDAS and other families, our software, at the website, you can see the at the our website of MIDAS Academy and Global Technical Center.